It says log base 125 of 3x minus 2 over 2x plus 3 equals 1/3. Okay? So again, what are my steps? Step 1 is going to be to isolate the logarithmic function. Yesterday we isolated an exponential function. And step 2 is I use an exponential to undo what I need to. Maybe that's vague, but maybe it'll help. I don't know. We'll see. That's how I think of these things, is I'm just undoing something when I do an inverse function. All right? So, by the way, for this particular problem, step 1, done. I already have the log isolated by itself. That's not going to be true for the other ones, okay? But once I have that, I can use an exponential to undo whatever I need to. All right? So the base that I want is this 125, right? I can take 125. Do you know what this means? If I write that symbol? To the is a nice way to say it. It's a caret, okay? To the, well, left-hand side, log 125, 3x minus 2 over 2x plus 3. And what that's going to do is that's going to eliminate the logarithm. Equals, but then I have to do it to the other side. 125 to the what? 1/3. Okay? Now that step that I wrote, I think most of you guys wouldn't be writing that. But that's okay, I want to show it. I want to show it anyways. Okay? Because now what happens is, on the right-hand side, I have 3x minus 2 over 2x plus 3. And what do I get on the left-hand side? Well, I have 125 to the 1/3 power. Do you guys know what that means? 5? How come? Yeah, because remember, when we have a fraction exponent, the numerator is the power and the denominator is the... What's the 3 mean? That's the root, right? And so when we say 125 to the 1/3 power, another way to write that is the cube root of 125, okay? So somehow or another, you have to end up with 125 to the 1/3 power, or the cube root of 5, is equal to 3x minus 2 over 2x plus 3. Now I'll be honest with you. What I just wrote down, a lot of you would have gone right from the original equation to there. Just because of what we've done before, right? Here's the base. Where does that go? Right here. There's the fraction. Where does that go? Right there. Because base to the exponent equals what's inside. Right? So if you want to skip all this, I'm okay with that. All right? But I'm trying to explain where it comes from so you understand. So now I get 5 equals 3x minus 2 over 2x plus 3. And now I guess it just comes down to, do you know how to solve this kind of equation with a rational function? We've done this before. You want to get rid of the fraction, right? So I would multiply both sides by what? 2x plus 3. On the right-hand side, then, it'll cancel. I think from here you'll have no problem. So I got -17/7 when I worked through that. This is the idea. Any questions on this one? All right, let's look at number 18. It says the natural log of x plus 1 minus the natural log of x equals 3. So it says first step here, we're supposed to isolate the logarithmic function, but here I have two logarithmic functions, right? So what should I do? What's that? Combine them, yeah. We have to use one of the log laws, right? So hopefully by now you guys know the 3 log laws, right? You could jot those down over on the side maybe. Let me put them right up here in orange. So one of them is the natural log of what? A product, AB, is equal to? Yep, there's my first one. My second one, the ln of a quotient, is ln of A minus ln of B. And again, it doesn't have to be natural log. It could be any log. I'm just writing them here with the natural log. And then number 3, let's see, what do we have? Oh, the most powerful log law, which is what? Natural log of, we'll say something to a power p would equal what? P times the natural log of A. So I think number 3 is the one we use the most in applications. But number 2 is what I want to use here. Do you guys see that? Because I see a subtraction sign. I'm subtracting 2 logs. So what I'm going to do is kind of use it backwards. I'm going to go from the right-hand side of the rule to the left-hand side of the rule. So what do we write down? There it is. We wrote it as 1 log. 1 logarithm. Okay? And now I'm going to do the same thing to both sides. What is it I'm going to do to both sides? Well, I guess the way to say it is e to the. Why did I pick e as my base? Well, it's natural log, right? If you want to undo a natural log, use e as your base. Okay? And so when you do this, the right-hand side is now just x plus 1 over x. And the left-hand side is, well, I guess e to the 3rd power. E to the 3rd power. And now we have to think a little bit, right? Can we do what? You could put e in your calculator, sure. Matter of fact, just to show you, there's a button on your calculator. I already showed you where e is on the calculator, right? Let's put it here so you can see it for a minute. Okay, here's my calculator. I showed you guys that right above the divided by sign, that little orange is e on the TIs. But the other one that's nice is, see this natural log? If you hit second in the natural log, see how it says e to the x? That's what I want to use here. You guys asked me what e to the 3rd power is, right? So I'm going to hit second e to the x, and there it goes, e to the, and it puts the open parentheses. And if I type in 3, there's an approximate value. 20, a little more than 20. All right, I may need that at some point. But for now, I'm just going to try and keep working on this. I'm trying to solve for which variable? X. But we have a problem because this is a rational function. I don't like fractions. I want to get rid of the fractions. What do you suggest I do to both sides? Sure, let's multiply both sides by x because then the x's will cancel on the left-hand side. And so I get, let's see, x plus 1 equals, well, boy, how am I going to write this? I guess I'll write it as e cubed x. You have to remember e cubed is a number. X is a variable. So I'd really like to get all the x's on one side. So my next step is, how about we subtract x from both sides? Okay? 1 equals e to the cubed x, oops, I said that wrong, e to the cubed times x minus x. Stop me if I confused you. Am I okay? Let me show you where mistakes are made sometimes right now is, can you combine these somehow? Well, no. But let me ask this. What's the greatest common factor of these two terms? The x. And that's kind of the key here. I'm going to rewrite this as 1 equals, let's take the x out and see what we have. What would you write? E cubed minus 1. All right? And sure enough, if you look at the answer given in your answer key, they're going to write it like this. X is 1 over e cubed minus 1, because they divide both sides by e cubed minus 1 and they get it. Okay? Now, I'm really glad we did these two examples in a row, because we kind of did the same thing in both examples. We had a fraction, a rational expression equal to something else, and we got rid of the fraction by multiplying both sides by the denominator. Right? That's what I did in this example too. So it's kind of good to see those next to each other. Okay? Okay. You know, I assign all these things, and it's like, have I really prepared you? I don't know. 24 is the same problem, but it has an equals. Yeah. So now we're going to do, hey, this is like your last exam. Remember that one page? You had an equation, then you had the inequality, right? All right. So how do we solve an inequality? Well, my suggestion was to use a sign diagram. That's how we've done inequalities for a long time now, right? Okay. So I'm looking at this crazy thing, and I'm saying, well, go, question? That's a good question, isn't it? Or are they the same? That's a good question. What the heck's going on here? All right, so let's see. Well, here, let's write them in the calculator and see what happens. So let me take the natural log. Give me an x. What should I use? Brad, I'll let you pick. 2. All right. 2 squared. Right? Yeah, that's awful. Let's put it here. So the natural log of 2 squared is 1.38. Okay? By the way, what's the natural log of 2, just so I'm... It's 0.69. Right? So now, what's going to happen if I type what they have on the right-hand side of this inequality? If I type in natural log of 2 with an extra set of parentheses and square it, what's it going to do? It's going to square that 0.69 thing, right? It's going to multiply that 0.6. Is it going to give me what's above? When you square 0.69, are you going to get that 1.38? Yeah. It didn't work, did it? See, this is a number less than 1, kind of like a half. What happens when you multiply a half by a half? Does it get bigger or smaller? Yeah, when you multiply a small fraction by itself, it gets smaller, right? Whereas if I multiply a number bigger than 1 by itself, it would get bigger. And now, actually, Jack pointed out something interesting here, which is that, did you guys notice that this number is half of that? In other words, if I do 2 ln 2, 2 times ln 2, I get that 1.38 back. Right? Why is that? Why do you get the same thing as ln of 2 squared? We can move the exponent. Remember I called that the most powerful log law, right? So we understand that those are the same in a sense. So, okay. So what do we do? Well, my suggestion would be this. Let's write natural log of x squared, and let's subtract the natural log of x squared and make that less than or equal to 0. Okay? Now, I guess I could graph it on my calculator right now and kind of look where this function is less than or equal to 0, and I could get an answer. But the directions say to solve the inequality analytically. See, what they want you to do, and actually this will also help you with number 24, is they want me to rewrite this side as a single logarithm. That's what I'd really like to do. So here's my hunch on what to do. We'll see how this works. I'm going to write 2 ln x right here. Does that seem okay to you guys? I just showed you that 2 times ln x is the same as ln of x squared. It's the most powerful log law. We okay? And now I'm going to rewrite this one like this. ln x, ln x. How does that look? Fair? Does this make sense? Because I get 2 ln x minus ln x equals 0, or less than or equal to 0. And now what I'm going to do is I'm going to notice that, oh, I have a common factor. I have an ln x. I'm going to pull that out. So I have natural log of x times, what would be left if I factor that out? 2 minus natural log of x is less than or equal to 0. And I think at this point, I'm going to try doing a sign diagram. Go ahead.
Why did you just take out the ln(x)(1)? Why didn't you take out the other one? Different factor that. Why did you take it out all the way?
Well, let's check. What I did was I wrote down ln x times 2 minus ln x, right? Okay, how do I check and see if that's correct? Distribute, right? When I distribute, you tell me, Matt, what would I get? Okay, you see it?
Yeah.
Good. So far, so good. I think at this point I'd like to do a sign diagram. So I guess what I'm thinking of, guys, is this kind of a problem. L times 2 minus L is less than or equal to 0. Is that something you'd be able to do a sign diagram for? If I just use capital L's? Because, here, let's make a line. This is an line with capital L's. And I want to know, what are the important points on what are the important values of capital L to think about here? 2, you're right. Or, if L is 0, that also could change things. You're right? Because these are the points where the output is 0, right? So I'm thinking that these are somehow important to the problem. Because if L is 2, we get 0, and if L is 0, we get 0. Now remember, L is going to actually stand for natural log of x in a little bit. But for now, this little substitution may help me. All right, so let's try a few things. Pick a number between 0 and 2. Nice job. Brad said 1. I don't know if you heard. All right, so what happens when we try L equals 1? Well, when L equals 1, now you can't see that, I'll move it over. When L equals 1, we get 1 times 1 is less than or equal to 0. True or false? That's false, right? 1 times 1 is positive. This whole interval here is positive if you plug in a 1. You guys with me? That's no good. All right. What happens if you plug in something bigger than 2? Like if L equals 3, I get a positive times a negative, so I get a negative. That's good, right? We want to be less than or equal to 0. Does this make sense? Why would it be negative? Okay. Positive times negative. You don't? Let me say it again. If I plug in L equals 3, I'll get positive 3 times 2 minus 3. So I get 3 times negative 1. And I claim no matter what I plug in from over here, once this gets bigger than 2, I'm going to be negative, right? And similarly, once L gets less than 0, what's going to happen? This guy will be negative, even if that's positive, so the whole thing's going to be negative, okay? So here's what I'm going to say. We want L to be less than or equal to 0, or L to be what? Greater than or equal to 2. That's right. If we want to satisfy this inequality, this is what I want. Question, go ahead. Yeah, but it does say less than or equal to. So I think these are okay, right? I mean, we want to include those. All right? Almost done. Why am I not done? Well, because I made up this thing called L. What is L, actually? All right, so what we want natural log of x to be less than or equal to 0, or the natural log of x to be bigger than or equal to 2. Now, do you guys know the graph of the natural log of x yet? If the answer is no, then I still have problems. If the answer is yes, you're in good shape. Let's assume the answer is no. All right, what am I going to do? I'm going to go to y equals, and I'm going to plot natural log of x, and I'm going to graph. And I'm going to say, okay, it kind of looks like that. I knew that. By the way, what's the asymptote for y equals natural log of x? There's an asymptote where? At 0. At what? At x equals 0. There's an asymptote. And then, what important point is there? This is the most important point. What is that? Almost 1, 0, right? Because this is the inverse function of the exponentials. And the exponentials all go through 0, 1. And so, if I asked you, where will we have an output less than or equal to 0? You'd say, well, that happens when x is between what and what? Between 0 and 1. Because as soon as I get past 1, what happens to the natural log? It's positive. Is this okay? Now, there's another way to do that. If you don't like, hey, I don't like knowing the graph. I just don't know it yet. All right? There's another way to handle this. And that is, you see how the natural log function is 1 to 1? It always grows. That means you can actually solve inequalities like equations. You don't necessarily need a sign diagram. That was the point of the last problem in section 4.3, and it's the point of the extra problem in section 4.4. is that all the stuff you did with sign diagrams, you don't need it. Here, watch. If the natural log of x is less than or equal to 0, how do I undo this? What do I do to both sides? E to the. Say that again, Brad. Oh, yeah, you're awesome. E to the 0. Now, what's e to the natural log of x? X. What's e to the 0? What's e to the 0? Anything to the 0 is 1. So we get x is less than or equal to 1 just by doing that. And you might get the right answer then. See, x is less than or equal to 1 is almost the answer. Why is it that I also have to be greater than 0, though? Well, because there's an asymptote. That's just the domain of natural law. Are you guys with me? Let's try this one. Let's do the same thing. Mario, what are we going to do to both sides? You could ask Brad if you're stuck. I don't know how to pronounce this. What is it? We're going to e to the. So what's e to the ln x? What's e to the, Abby Hobbs, what's e to the natural log x? X. Nice. X is bigger than or equal to what? Delaney wants that. Bigger than or equal to what? Oh, what did we do to both sides? We did e to the, right? So we get x is bigger than or equal to what? E squared. She didn't want to say e to the 2, because that was just e squared. So x is bigger than or equal to e squared? Really? Let me show you that. Here's my calculator. Where is e squared? I have no idea. So I'm going to do this. I'm going to hit second calculate, the trace button. Second calculate a value. And it says, what x value do you want to put in? And I'm going to type in, well, second, and then this natural log, so it types e to the 2. I don't even know what e squared is. It's around, well, e is about 2.7. So e to the maybe 5 or 6 or something. Let's see where it goes. There it is, 7.38. So I was wrong. Comma 2. You guys see that? So what is that on my picture? If I were graphing it, I would go like this. I'd say, well, that's e squared, comma 2. That's one of the points for now.